So today we're doing product, quotient, and power rule. So on your formula sheet, the very first one we're going to go over is the power rule. Like, seriously. Stop. The power rule is the very first one on your formula sheet. It's log base b of m times n. I can rewrite that as interchangeably log base b of m plus log base b of n. So I can take a log base of something that's being multiplied together and I can expand it out as an addition. And the reason why this is a double arrow is because I can take something that's expanded out with the same base addition and I can put it together as multiplication. You can go back and forth with these. Okay? Along with this is the product rule. Along with that rule is the quotient rule. Which is log base b of m divided by n. You can separate with a subtraction. One thing I want to show you, seriously, is that these have to have ones in front. So this has to have a 1 in front of it in order to expand it out. These have to have ones in front of them in order to put them back in. So they can have a plus or minus 1 in front of the logs, but you can't have a number in front. If you have a number in front, we're going to use the power rule, which will come up in a second, in order to do it. Now I want to show you something, because often people think that these are like completely separate of each other. But basically, anything that has multiplied on the top, you can rewrite out with a plus 1 in front, and anything that's divided by in the bottom, you can write out with a minus 1 in front. So I'm going to show you one where they're together just to prove a point. So if I had log base b of m n over xy, let's say, I can use both the product and the quotient to draw this out. Okay? There's no, like, people are like, oh, so the first one gets added and the second one multiplied or divided or subtracted, and they try and make rules. All you need to know is that if you want to expand this out, anything that's on the top gets a plus 1 written in front of the log. Anything that's in the bottom gets a minus 1 written in front of the log. If you can do that, life is easy. You don't even need the formulas to memorize. Okay? Plus they're on your formula sheet, so there's no point. So I can rewrite this ugly one out as positive 1 log base b of m, positive 1 of log base b of n. Because they're both on the top, they get a plus 1 put in front of them. Now the only difference is, do I put a plus 1 in front of the very first one? Usually, do you see a plus 1 there? No, it's usually just written as log base b of m. But if it doesn't have something in front of it, you assume it to be a plus 1. Okay? And then the bottom ones are in the denominator. When they're down there, you're going to go negative log base b of x, negative 1, I guess, negative 1 log base b of y. So anything that's in the bottom gets a negative 1 written in front. Anything that's in the numerator, the top, gets a positive 1 written in front. Okay? So yes, these formulas can be used together, and it confuses people when they're used together. So I like just proving that right away, that you can mix them. The biggest stipulation is that they need to have plus or minus 1s in front. Okay? And this log here has a plus 1 in front, because even the formula sheet has a plus 1 in front. So we're going to go to some real examples. Expand. A. So we're going to expand log base 6 of x squared plus log base 6 of y squared. Expand. I wrote out the answer. Whoops. I know, thanks. It should be written like this. Expand that. Because they're both in the numerator, we'd get what I had just written, which was really cool. Log base 6 of x squared plus log base 6 of y squared. You could put a plus 1 in front of here, but there's really no point. There's one extra step we could change this to, but we'll do that after once we put power rule. B, log base 2 x, y over z. You try it out. See if you can do it. So when we expand this out, we're going to get positive 1 log base 2 of x, because x is on the top. Positive 1 log base 2 of y. And then negative 1 log base 2 of z. Now you don't need the ones in front, so this could just be log base 2 of x less u plus log base 2 of y minus log base 2 of z. Yeah, with special rules. Okay. Okay. C. Log base 3, 6 times 4 over 2. So we're going to get positive 1 log base 3 of 6 plus 1 log base 3 of 4 minus log base 3 of 2. Okay, what if I ask you instead to write as a single logarithm? So my only rules when I tell you that you have to write it as a single log is that they have to have plus or minus ones in front of them, right? As of now, that's all they're going to have. In a little bit, we're not going to have that same option. This is a plus 1, minus 1, minus 1. The only way we can put them together is if they have the same base, which these all do. They're all base 2, right? So we want to write it as a single logarithm, and the spotting to write these, whenever they're all the same base, is a huge hint that you're going to be putting them together. Okay, huge hint. So if you see log base 2, anything with a plus 1 in front stays on the top. Anything with a minus 1 in front goes to the bottom. So this one has a plus 1 in front. So A stays on the top. This has a plus 1 in front. So B stays on the top. This one has a minus 1 in front. So C goes to the denominator. And minus 1 in front. So D goes to the denominator. And anything that's left on the top and the bottom just gets multiplied together. So it's going to be A times B over C times D, which I'm just going to leave as A, B, and C, D. So you try this. Try that one out. So this one has an extra step at the end because you have, if you have the same letter in the numerator as you do in the denominator, you're going to have to simplify. So log base 3, anything that has a plus 1 in front goes to the top. Anything that has a minus 1 goes to the bottom. So c squared on the top, d on the top, c on the bottom, d cubed in the bottom in the denominator. Then I say, hey, I have 1c. These don't have plus or minus signs in front of them. If they had plus or minus signs connecting them, I could do nothing, right? Just like rationals, they have to match exactly the same in order to. But these are being multiplied. Remember, when anything's multiplied, you can put it in its own brackets if you really wanted to. Remember rationals? So I have 1c down here and 2c's up here. So I can take 1c out for 1c. So I'm still left with a c up top. Okay? I have 1d in the numerator and 3 d's in the denominator. So I can cross this d off with one of these, and I'm left with a 2. So what am I left with in the end? Log 3 with a c in the top in the numerator and a d squared in the denominator in the bottom. Okay? Now, what if I said simplify, because I can't write it as a single logarithm, because I'm going to have a few different log bases. If I have more than one different log base, so this last one I had, they were all log base 3, so you can write them together as a single log. However, if I have like 2 that have log base 3 and 2 that have log base 2, I can't write single logarithm because you can't put them together. You can only put together the same base. So then I have to say simplify. So say I have simplify log 2m minus log 3n plus log 2n minus log 3m squared. Try that one out. Remember, you can only put together the base 2's and you can only put together the base 3's. All right. So I can write this as log base 2. Because it has a plus 1 in front, the m stays on the top. This is the other one, and it has a plus 1 in front, so the n stays on the top. So there's no denominator. Then we add to it log base 3. This has a negative 1 in front, so it goes to the bottom. This has a negative 1 in front, so it goes to the bottom. So this one had a 1 in the denominator, mn over 1, but I didn't have to write the 1, correct? Because it's in the denominator. Do I have to write the 1 up here? Yes. If the 1 is in the numerator, you have to write it. But if the 1 is in the denominator, any number is over 1. So like the number 7, you can write as 7 over 1. We just don't, correct? But if I had the number 7, I could write it as 7 over 1, but we don't. We would just write it as 7. But if I had the number 1/7, could I just write that as 7? Is 1/7 7? No. I have to write the 1. Okay? So that would be as low as I can make this. Now, it would be sweet if they always gave us plus 1s and minus 1s in front. But they don't. So therefore, we have to use the power rule. The power rule is, I should use the same letters as the formula sheet. So the power rule helps us so that if there is a number in front of the log, I can move it somewhere as the exponent, right? And then life is good. Then I can do my lovely rules. So it's log base b of mn can be the same, it's double arrowed again, as n log bm. So basically, I can take this n, this coefficient of n, and I can bring it up as the exponent. Or I can take this exponent and I can bring it in front as my coefficient. That's the power rule. And this power rule helps us so that when I ask you to write a single logarithm, but there isn't plus or minus 1s in front, there's numbers in front, that you can move those numbers up as the exponent, and then you're left with plus or minus 1s and can put it together. Easy question. A lot of people get it wrong on the test because they forget to move the number up and they either just ignore those numbers or they do some crazy math in front. Okay? But the formula on the formula sheet says for product rule and quotient rule, I can only use those formulas if there's a plus or minus 1 in front. Okay? So, an example. Write as a single logarithm. Okay? A. 7 log b x plus 3 log b y minus 2 log b x minus 4 log by. Okay, so looks exactly the same as the last one, except there's coefficients. There's a 7, there's a plus 3, there's a negative 2, there's a negative 4. And I can't put anything together as a single logarithm if there are numbers in front of the log. If there's coefficients, I cannot put it together. I need them to be coefficients of 1 or minus 1. So I need to use power rule first. A lot of you forget about it and just put this together because you see the b's and you're excited. And like I said, I don't know what you do. You kind of just put the x's and y's. You treat them like we did before, and then you do some crazy math with the numbers in front. Okay? Don't do that. The very first step you have to do is bring these up as the exponent. And then you're left with plus or minus 1s because we're using the power rule. So we're going to have log base b x to the 7 plus log base b y to the 3 minus log base b x to the 2 minus log base b y to the 4. Do you see how I don't take up the negative 4? I don't take up negative 2. I just take up the number. I don't take the sign. Okay? That sign still stays minus. Just the 2 came up and just the 4 came up. Right? I didn't take the sign with me. And now we're back to a question we did before. Try and do it. With the C's and D's, we did one. So we have log base b. X to the 7 is on the top because there's a plus 1 in front. Y cubed is in the numerator because it has a plus 1 in front. X squared is in the denominator because it has a minus 1 in front. Y to the 4 is in the denominator because there's a minus 1 in front. Now at the top I have 7 x's. And in the bottom I have 2. So 2 cancel and I'm left with 5. In the top I have 3 y's, in the bottom I have 4. So 3 cancel and I'm left with 1. So my answer is log base b of x to the 5 over y. Okay, one last one. What if I say expand? And I give you log. Most people are really good at noticing, like putting it together as a single logarithm because it's a whole bunch of logs with the same base and kind of like, I don't know, a little light bulb comes off and you see a whole bunch of bases. Most people are really good that way. Most people forget how to take it from a single log and separate it out to expand it. That's the one that people forget. So if we have log base 6 of x squared y cubed over z to the 4. We did an expanding like this before in an example. And I let you guys just leave it at like log base 6 of x squared. And I told you that this is an answer, but you can go a step further once I teach you power rule, but we're not going to do that right now. We're going to do that right now. So let's expand it out. Anything that is in the numerator gets a plus 1 in front. Anything that's in the denominator gets a minus 1 in front. So let's do that first. So we're going to get log base 6 of x squared. And if you want, you can put a plus 1 in front of it. Or you can just leave it the way it is because that is a plus 1, right? Then the y cubed, I get plus 1 log base 6 of y cubed. And then I'm going to get minus log base 6 of z to the 4. And before, when I did this example, I said we're done. This is an answer. But I said we could go further. We just don't know how right now. What's the one last thing we could do now that we know power rule? Yeah.
Move the 2, 3, 4 to be.
Right. Move the 2, 3, and the 4 to be the coefficients in front. So we're going to get 2 log 6x plus 3. We're going to move these babies in front. When we move them in front, they just multiply by the number that's there already. So it would be 2 times 1, which is 2. 3 times 1, which is 3, log 6y. And then 4 times negative 1, which is negative 4, log 6z. And now we'd be done. Pardon? Yes. Yeah. Textbook, page 446, numbers 1 to 16.